All right, we are working through our lesson 7 practice problems all over angle relationships and transversals and parallel lines. So let's jump in here. Let's look at these top 6 problems first. So it says classify angles 1 and 2 on the diagram as one of those 5 angle pairs. All right, so let's take a look at number 1 here. Okay, so I always say first look at your transversal line. So here's our transversal. Are the angles on the same side of that transversal or on opposite sides? Well, they are on opposite sides, okay? So I know it's not gonna be like a same side type of angle relationship. It's gonna be an alternate one. All right, so it's either alternate exterior or alternate interior angles. The way to determine the other word, interior or exterior, is by looking at the other 2 lines. So let's look at the other 2 lines. Are they in between those lines or outside of them? Well, they're both in between them. So we'd say they're on the interior. So this would be an example of a pair of alternate interior angles. I'm just going to put alt-int angles. I'm just going to abbreviate because that's a lot of writing. Okay, I think that's all it wants us to do for that. All right, let's take a look at number 2. So again, locate your transversal line, and that is the one that cuts through the 2 others. So here's my transversal. Now these are on the same side of the transversal. 1 and 2 are on the same side of it. All right, so let's determine now if they're either same side interior or same side exterior. To determine interior or exterior, we look at these 2 lines. And are they in between them? No, they are not. So they are on the exterior of those lines. So we would say this is an example of same side, I'm going to put SS, exterior angles. And the way I'm drawing the angle, sometimes I draw the little arc through it. This is just a tedious little side note, this little arc that I did over here. That's just a way to show that it's an angle, or you can do just like a regular looking kind of a less than sign, but to differentiate, some people draw an arc through it. Okay, number 3. All right, so same thing, let's look at the transversal. Now our angles are on the same side of the transversal, but this is a little bit of a tricky one because look at your other 2 lines now. We might think they're like same side interior or exterior, but if you look at these 2 lines, one of them is on the interior, but one of them is out on the exterior. When this happens, it's not actually a same side situation. These are corresponding angles, kind of the odd one out. Corresponding is like its own thing. Corresponding angles. That's it. So anytime they're tricking you into a same side relationship, but one is inside and one is outside, those are always going to be your corresponding angles. Okay, number 4. Let's look at our transversal line first, always. Now they are on the same side of it, and then if you look at our 2 other lines, they are both on the interior of it. So we would say these are same side interior angles. Number 5. Okay, let's look at our transversal line, and they do appear to be on the same side, so we might think they're a same side relationship. However, this is like that other one. One is on the interior, or number 2 is, and then angle 1, the other angle, is on the exterior. So don't be tricked. This is that special one that's called corresponding. Corresponding angles. That just means that they're in the same position. Like they're both on the same side of their line and they're both above their individual line. So they're in the same position. Okay, number 6. Let's find our transversal. Here's the line that's going through the 2 others. Our angles on this one are not on the same side. They're on opposite sides, or we could say alternate sides. And then if we take a look at the other 2 lines, because they're either alternate exterior or alternate interior, here's our 2 lines. They're not on the interior. They're both on the exterior. So we would say alternate exterior angles. Alternate exterior angles. Okay, so that was just kind of a little vocab round right there. Let's look at example 7. So it's got part A, B, C, D, E, F, G, all for number 7 here. They give you the measure of angle 6. They tell you it equals 142 degrees. And then based off just that, they want you to find each measure. And then it does say give your reasoning. So if you want to be extra thorough right here, you should do that. Your teacher will probably ask you to do quite a bit of things like that in geometry, justifying your answer. Okay, so the measure of angle 6, let's locate that. Angle 6 is right here. That's this guy right there, and they tell us it's 142 degrees. Okay, so based on just that angle, they want you to find every single other angle. Okay, this is like way easier than you may realize. And you don't have to go in order here. I guess we could go in order because I would find angle 1 next because that's going to be your easiest one. Those are vertical angles, and we know those are always congruent. So this also has to be 142 degrees. So let's write that in. Angle 1, we would say, is 142 degrees. We could say the reasoning, we could just say angle 1, we could say it is vertical to angle 6. So this angle 1 is vertical angle 6. All right, that's enough of a justification there. Okay, angle 2, we could probably find that one next. There's so many ways to do this. The way I look at it, so here's angle 2. I always look for my straight lines because I know straight lines measure 180 degrees. So that means from here all the way to here has to be 180. So I can simply do 180 minus this angle, the 142, to get the one right next to it. So 180 minus 142, what is that, 38? Yeah, 38 degrees. Okay, so that has to be our angle 2, 38 degrees. So we could say, if you want to use good math vocab, we could say angle 2 and angle 6 are a linear pair. So let's say angle 2, I'll just go like this, and angle 6 linear pair. If you don't remember that term, we learned it on the last lesson if you want to go watch that video. Okay, you know what? I would finish up this little section right here. It goes to angle 3, but I would actually answer angle 5 next. So angle 5 is part E right here. And that's super easy because angle 5 is the same as angle 2. Those are vertical angles. So 5 would also have to be 38 degrees. I could say it is vertical. Angle 5 is vertical to angle 2. Okay, now the rest of these are going to be super easy because we know all of these. They're basically all corresponding to one of these over here. And we learned that corresponding angles are congruent. So I know angle 1 and 3 are corresponding, so those are going to be the same. So let's go ahead and answer that angle 3 is 142 degrees. We could say because that's corresponding, oh, big word, corresponding with angle 1. So angle 3 is corresponding with angle 1. Okay, for the same logic, let's answer angle 4 right here. If I circle angle 4 down here, that one is corresponding up top here with angle 2. So those have the same measure. So if that's 38, this one is also 38. So that's 38 degrees. I could say that is corresponding, angle 4 is corresponding with angle 2. That would be my logic there. And then we're just left with 7 and 8. And it's going to be the same justification. So angle 7, that would be corresponding with angle 5. So it's also 38 degrees. 38 degrees. You could also go through different logic, y'all. If you're looking at angle 7, you could also say, oh, well, it's vertical to angle 4. So that's another reason why those are equal to each other. You know what? I'm going to go with that. I'm going to say angle 7 is vertical to angle 4. And we already found angle 4. So that means they're the same. All right, and then last one, we have 8, which we might as well say that's vertical to angle 3. So if those match, then they're both 142 degrees. So So I'm going to say it is vertical. Angle A is, vertical to angle 3. All right, that would be enough of a justification for that one. Okay, so now we're getting into the part where we're actually setting up equations and solving for x. And then we got a few on the other, the kind of second part of this sheet. So let's read through the directions here. Now, make sure you understand what this means. If I read this out loud, this is a special symbol that you should know. And that symbol means parallel to. So this is saying if L is parallel to M. So take a look at number 8, saying this line is parallel to this one. Okay, so that's the same for all of these. So if L is parallel to M, classify the marked angle pair and give the relationship, then solve for x. All right, so number 8 here, let's classify this special angle pair. So we've got an angle here and here is what we're looking at. So let's always find our transversal first. They are on the same side of that transversal, so maybe it's like a same side situation, but don't get tricked, because if you look at these now, you do have one of them on the interior, but one on the exterior. Remember the word we used for that? Those are corresponding angles. Corresponding. And then it says classify, give their relationship. So basically they just want you to write, okay, if they're corresponding, does that mean that they're congruent or they're supplementary? And this is one that you'll just have to memorize. Corresponding angles, if you have parallel lines, are always congruent. So we're going to write 2 words for each of these, corresponding, congruent, and now we want to solve for x. So if you have 2 angles that are congruent, that means you can literally just set them equal to each other and solve. That's it. That's how you'll do it every time. So I'm going to set this equal to this. So I've got 5x minus 2 equal to 58. And solving that, I'm going to first add my 2 to both sides. So I guess I can show my work. So I would get 5x equals 60. And then we're dividing both sides by 5. So we're going to get x equals 12. And then we're done. So corresponding, congruent, and 12. Those would be like the kind of 3-part answer here that they want. All right, same with number 9. Let's look at these angles. So we have one up here and we have one down here. All right, let's find our transversal. Now they are on opposite sides, so this is going to be one of the alternate angles, so it's either alternate interior or alternate exterior. Now to determine the second part, we look at these 2 lines. And neither of them are in the interior, they're both on the exterior. So we would say this is alternate exterior angles. I'm just going to put alternate exterior, and if you remember from the notes, those with parallel lines, those are always congruent. They're basically all congruent except for your same-siders. Same side interior and exterior, those are the supplementary ones. Okay, which means I can just set those equal and I can solve for x. So let's do that. We've got 16x plus 22 equal to 134. We would subtract 22 from both sides. I'm going to skip showing the work because y'all know what I'm doing here. So 134 minus 22, that's going to give me 112. And then dividing both sides by 16, I'm going to get x equals, that's going to give me 7. And then that's it. So here's all my answers there. All right, jumping to number 10. Okay, so they kind of show an arrow to this angle. So on this one, we're looking at this angle and this angle. So let's find our transversal. Those are on opposite sides, aka alternate sides. And then if we look at these lines, those angles are both on the interior. So this is going to be alternate interior. Okay, and then we know alternate interior angles with parallel lines are always congruent, which means we can set them equal to each other. So I'm going to set 7x minus 1 equal to 125, and then we solve. Let's add the 1 to both sides. So I'm going to get 7x equals 126. And then you're going to divide both sides by 7. So we'd end up with, what would that be? X equals 18. Good. All right, number 11, let's look at those angle pairs. We got one here, that's where the arrow is pointing, and then one right here. So if we draw our transversal line, or we highlight it, they are both on the same side of that line. Okay, so they're same side, and then let's look at the other angle pairs here. And then both those angles are on the interior. They're all on the inside. So we would say this is an example of same side, I'm gonna go SS, same side interior angles. And now if you look at your notes, same side interior angles, they're not equal to each other, they're not congruent, they are supplementary, meaning they add to 180. And if you don't remember that word, look back on our last lesson where we went over all this vocab. Supplementary. So same side interior, supplementary. Now be careful. The common mistake here is to set those equal to each other. But don't be that person, because those are not equal, okay? But I do know if I add them together, they equal 180. So that's exactly what I'm going to do. I'm going to do this plus this equals 180. 9x plus 2, I can drop my parentheses, plus 133 equals 180, and then I solve. I have a couple of like terms I can combine right here. So I've got 133, and the 2 can be 135. So I have 9x plus 135 equals 180. From there, I would subtract the 135 from both sides, which would give me 9x equals 45. And then divide both sides by 9. So we get x equals 5. Good, y'all. Zoom out here, you can see all of it. And let's go ahead and finish this up on our other one. Uh-oh, I have that one filled out. I'm gonna clear that. Okay, let's work through them. Okay, we've got two angles right here. Let's locate our transversal. And now those are on opposite sides, which we call alternate sides. So they're alternate something. So let's look at these lines. And they're not in the interior, they're both in the exterior of them. So we would say this is alternate exterior angles. All right, and then we know with parallel lines that those are going to always be congruent. So these are the simple ones because you can just set those things equal to each other and then solve. So let's do that. Let's set this equal to this and see what we get for x. From here, I would probably subtract the 3x first from both sides. So 8 minus 3, I would get 5x on this side, minus 77 equals 38. And then from there, I would add the 77 to both sides. So we'd get 5x equals 115. And then divide both sides by 5. So x would equal 23. All right, number 13. To locate our angles right here and right here. So if we look at the transversal line, they are both on the same side. However, if you look at these two lines, one is in the interior, one is in the exterior. So these are the kind of the weird ones that we call corresponding. Corresponding angles. And corresponding angles with parallel lines are always congruent, which makes our job pretty easy because we are just going to set those equal and solve for x. So I'm going to set 11x minus 47 equal to 6x minus 2. Okay, from here I would probably subtract the 6x from both sides. So subtracting 6 from 11, that's going to give me 5x minus 47 equals negative 2. And then I'd probably add the 47 to both sides. So we'd get 5x equals 45. adding 47 to -2, and then divide both sides by 5, so we get x equals 9. Okay, I only have 3 left, and this last one's kind of a bonus one here. That one's a little tricky. Let's look at number 14. Okay, so looking at these angles, I've got one here and here. If you identify that transversal line, they are on opposite sides of it, so it's going to be alternate something angles. And then let's look at these 2 lines. And those 2 angles are both on the interior. So we are dealing with alternate interior angles. Alternate interior, which we know are congruent when we're dealing with parallel lines, which means we can set them equal. So I'm going to set this equal to this, and then it's just algebra from there. Okay, from here I'd probably subtract 5x from both sides, which would give me an 8x on this side, minus 21 equals 75. Then I would add the 21 to both sides, so I'd get 8x equals 96, and then divide both sides by 8, and we get x equals 12. Good. Okay, number 15, then we'll do our bonus. Okay, let's look at the angles they give us here and here. Now, if we highlight our transversal, they are on the same side of that transversal, okay? And then if we look at these 2 lines, it looks like they're both on the exterior of them. Nothing's on the inside. Exterior angles here. So we would say these are same side exterior angles. Okay, which be really careful. We've only done, I think, maybe one other like this. So careful with the setup. Do not set them equal. Do add them together and set them equal to 180 because they are supplementary. Supplementary. Okay, so add them up. So let's do, really doesn't matter which one you start with. I'll start with the one up here. 9x minus 33 plus 5x plus 3, and that all has to add up to 180. Let's go ahead and simplify that side down. So adding 9x and 5x, we get 14x. We also have negative 33 plus 3, which is negative 30. And now we solve. Let's add the 30 to both sides. So we get 14x equals 210. And then we're going to divide both sides by the 14. And we get x equals 15. Okay, that takes us to our final problem here. So if you're down to try the bonus, let's do it. Okay, this one is a bonus because if you notice, it's got multiple variables. It says if L is parallel to M, find the value of x and y. So what I recommend doing on ones like these is solve for one variable first, and I would probably focus on finding x first. Let's take a look at that. So if you look where your x variables are, there's one right here, and there's one right here. Let's see if we can make an equation involving those 2. Now, here's our transversal. They are on alternate sides of it, or opposite sides, and they're on the interior of this. So since they're alternate interior, I know that they're congruent, which means I can set this equal to this. So that's the first thing I would do here. I'm going to do 8x minus 31 equal to 6x plus 3. Okay, from there I would subtract the 6x from both sides, so I would get 2x minus 31 equals 3. And then I would add the 31 to both sides, so we get 2x equals 34. Divide both sides by 2, we get x equals 17. Okay, so that wasn't too bad. We have our x variable. Tricky part is we got to find our y variable. So here is where our y appears in this angle here. There's a lot of ways you could go about it from here. I'm going to take what we got for x, 17, and I'm going to plug it in. I don't know, let's plug it in for this one. And if we do that, we'll figure out what this angle actually equals, like the number that it equals. So let's do that next. Okay, so I'm gonna just draw a little arrow over here. So I'm gonna take that little 6x plus 3 degrees, and I'm gonna sub in 17 for x right here. So I'm gonna do 6 times 17 and then plus 3. So 6 times 17, that gives me 102. I'll write that down. So we're doing 102 plus 3 degrees, and that's going to give me 105 degrees. So we just found the measure of this angle right here. Okay, I'm just going to write here, that is 105 degrees. Now that's going to help me because I can use 105 and somehow relate it to this angle that involves the y. So take a look at these two angles that we're looking at right now. Now here's my transversal. They're on the same side of it, and then if we look at these two lines, they're both on the interior, okay? So we would say these two angles together represent same side interior angles, and same side interior angles are supplementary. So now I can take this and I can add it to 105 and set that equal to 180. I know, that's a lot, but that's what I'm gonna do out here, and that's why this was bonus. So let's do 5y, kind of looks like an x, 5y plus 35, and add to that 105, the angle we just found, and we know those have to add up to 180. Okay, let's go ahead and solve. So 35 plus 105 is 140, so we get 5y plus 140 equals 180. Let's subtract 140 from both sides. So we get 5y equals 40. And then divide both sides by 5. We get y equals 8. That would be our second solution. That was definitely the harder one to find of the two, for sure. Okay, hopefully that went well, y'all, and I will see you in our next video. Good job.